If I recall, we left off, we were talking about even and odd symmetry, but we barely got to talk about it. Or maybe we hadn't even made it that far. We did an example with local maxima and local minimum, yes? All right. The very next thing after that is even and odd symmetry. Did we? Did I write the definitions?
Yeah.
Well, let me write them again. Did I draw pictures too?
Yeah.
Oh, well, I don't think I did in the other class, so we'll write this real quick, considering I'm making a video. And so if you already have this, you don't have to write it. So a function is even or has even symmetry if f of negative x equals f of x. And remember, I drew a picture that was something like this. And we said that an even function had y-axis symmetry, so that if I came out to some value of x, and if I came out to some value of negative x, they come out the same. A function is odd or has odd symmetry if f of negative x equals negative f of x. And then chances are I drew this picture because I draw almost the same picture every time I teach this. And then I probably did this. And then I did this. And then I did this. So the idea is that's f of x. And if this is negative x, then this would be the opposite of f of x. So the output comes out to be the opposite. This is called origin symmetry, because if you rotate that graph 180 degrees about the origin, you end up with the same graph. Bless you. Now, let's do some examples of figuring out whether a function is even or odd. Does anybody need more time on this page? All right. So let's say that f of x is x cubed minus 6x I'd like to know whether that's an even function or an odd function. So the way you check is you compute this and you see how it turns out. How would I compute that? Not exactly. Say that one more time. So I plug in negative x wherever there's an x. So this would be negative x cubed minus 6 times negative x. What's negative x cubed? It'd be negative x cubed, because when you raise something to an odd power, it'll preserve the minus sign. what would the next piece be? How does that relate to that? It's the opposite. So since it's the opposite, that would mean that this is odd. If it comes out the exact opposite when you plug in negative x, it's odd. So, let's figure out this one. So I plug in negative x wherever there's an x. What will I come out with? All right, so this is x to the fourth. Now be careful there. You got to square first. When I square x, or when I square negative x, what would I come out with? Positive x squared, and then this is negative 2, right? So this would be still minus 2x squared. And then the 17 doesn't change either. How does that compare to the original? It's the exact same. That would mean that this function is even. All right, this one is x squared plus 2x plus 1. What would we get out of this one? Yes. This is x squared minus 2x plus 1. How does that compare? Is it the same? Is it the opposite? Take another look at it. It's not the opposite. Only this small piece of it is the opposite. The rest of it's the same. So since this is not the same, nor is it the opposite, then this is neither even nor odd. Most functions are neither even nor odd. It takes a special type of symmetry, like I showed you in the picture. So this would be neither even nor odd. Did you guys notice a pattern in this at all? This one was odd, right? Did you notice anything interesting about it? That's true. The powers are all odd, aren't they? If you look at the one that's even, the powers are all even because even though this is a 17 here, this is almost like 17x to the 0, because x to the 0 would be 1. And so that is technically an even power there. So if all the powers are even, then your function's even. But you notice here there's a mixture of even and odd powers. There's a squared, there's a 1. So that's why that one's neither even nor odd. Now, on a test, if you're going to use that, write me a little note about it so I know you didn't just get a 1/3 chance of getting it right by guessing. Understood?
Mr. Walsh.
Like I was saying, if you're going to use that technique, just make me a note about it. Understood? All right, now I know how I like to write tests. I'd like you to consider the following. Do you think this one's even, odd, or neither? You would think that. That's actually not right. It's actually odd. Now, let me show you why. Let me do this formally, and then we'll wave our hands at it to kind of get an understanding. So clearly the top part's even, right? We understand that based on the discussion that we had on the previous page. And clearly the bottom part is odd. So the top part is going to stay the same, and the bottom part is going to change sign, right? Now, somewhere off in Scratch, I want you to consider the following example. Those two are opposites, are they not? Now, technically, we don't put the minus on the bottom, but in theory, you could. That's the same situation I have here. This would also be the opposite, would it not? So as a result, this is odd. So to have an understanding, if you have odd over even, or even over odd, that's odd. I should hope that you would know that even over even would be even. What do you think odd over odd is? It's even, because think about it this way. If you had odd over odd, that'd be like this. And the negatives essentially cancel out. So odd over odd is even. And then I always get asked, well, Mr. Walsh, then what would make it neither? If either the numerator or the denominator were neither, then the whole thing would be neither. So if I had like x squared plus 17x, the numerator would have been neither even nor odd, so the whole fraction would have been neither even nor odd. Make sense? All right.